This section is probably the most, if not definitely the most, is one of the most important sections you're going to cover all year long. What we're looking at in this section is how you get quantitative amounts of reactants and products, otherwise known as stoichiometry. Stoichiometry is a big word, basically saying is given one quantity of a substance in a chemical reaction, you can use it to predict how much of another reactant is needed or how much of a product is going to be formed. And this is one of the most useful or most widely used things you're going to need when you go to college or if you take another chemistry class. When you do stoichiometry, there's a diagram that we use that sort of helps us think through where we're going to and where we're going from. It all begins with the chemical equation. So in the last section, we talked about writing chemical equations and being able to predict them. It's essential that you write formulas correctly. So when we talked back in Chapter 2 about writing a formula, if you can't write a chemical formula correctly, then you can't write a chemical equation. If you can't write the chemical equation correctly, then you can't balance the chemical equation correctly. If you can't balance the chemical equation correctly, then none of the stuff we're going to do here you can do correctly. So chemistry, unlike everything else, really does build upon itself. All right, so let's take a look at how we go about doing a stoichiometry problem. In a stoichiometry problem, the first thing you're always going to do is you're going to balance the equation. All stoichiometry begins with a balanced equation, so always make sure that's done. Once you have a balanced equation, you should always look underneath it to see that everything that you are given is broken down. So for example, in the problem I've given you in your notes, and this is out of the book too, you might not be able to see it too well on the screen, but refer to your notes, it's definitely there. In the equation here, we have a balanced equation already. So part 1 is taken care of for us. Part 2 tells us to write down what all information we know or we're gathering and we want to know. So from the problem I read, it says the food we eat is degraded or broken down in our bodies to provide energy for growth and function. A general overall equation for this reaction process represents a degradation of glucose to carbon dioxide and water. That's a it's a combustion reaction. Our body is burning that food. Now, here's the information we were given about that reaction. 856 grams of glucose is consumed by a person over a period of time. What mass of carbon dioxide is generated? All right, so the information we know in step 2 is that we have 856 grams of this substance. So underneath the equation, I write down what I know. It's sort of a visual organization to keep you track of where you are and where you want to be. Now, what do we want to know from this problem is we want to know grams of CO2. So underneath CO2, I put grams, question mark. Now, the third step now that we know everything we want and know what we want to find, we refer to our diagram above. And our diagram above is sort of a way to step you through how to get your answer from what you're given. If you are given a mass, you then need to convert that to moles. And the way we do that is multiplied by 1 mole over the molar mass of the substance, or molecular mass in this case. Once you get to moles given then, you're going to multiply by the mole ratio, which is what you want over what you have, and we'll refer to that in a second. It's using the coefficients in the equation to give you a ratio of moles of one thing to moles of another in the reaction. Finally then, to get to grams of your wanted substance, you're going to multiply by the molar mass of your wanted substance over 1 mole. It's important that you know that you can start on either one of these two things. It's possible that you would be given a moles of a substance and asked to find something else. It's possible you may only ask to find moles of a certain product. So be careful what the problem is asking you to. You do not have to go full step from one end to another. In this problem, we are given grams, so we're starting here. We want to find grams of a different substance, so we're ending here. So we will, in this problem, go all 4 steps. Now, to set up that problem, we start stepping our way through it. I have the example laid out for you. And in that example, we start off by taking what we are given, the mass of the CO2. So mass of CO2 will equal the mass of our glucose, 856 grams, times 1 mole over the molar mass of glucose. That gets us from grams given to moles given, times the ratio. Now, where do we get the ratio from? The ratio is 6 CO2 over 1 C6H12O6. Now, remember above I said when you set your ratio up, your ratio is what you want over what you have. In this problem, we want to find this substance. The coefficient in front of that substance is a 6. So it's 6 moles of CO2 over the substance we have to begin with, which is 1 C6H12O6. So that is where the number 6 and the 1 come from. The final thing is then multiplied by the molar mass of the wanted substance. So the substance we want to find is CO2. So we figure out the molecular mass on the side of 1 carbon and 2 oxygens added together, and we get 44 grams of CO2. Now this problem is from the book. It's copied out of the book. So they've rounded 2 decimal places for this. Again, remember I told you always go to 1 decimal place off the periodic table. Mathematically then, grams of C6H12O6 cancel out, moles of C6H12O6 cancel out, moles of CO2 cancel out, and we're left with just grams of CO2. In a stoichiometry problem, if you can't cancel out everything and you're not left with the units you're trying to find, then you have something set up wrong. That is one benefit of stoichiometry, and one of the positives of it is that you can always tell if it's set up correctly or not. Now let's do another example together. And again, if you want to try to do this one on your own, pause the recording at this time and then continue when you're ready. In the following reaction, how many grams of O2 are formed from 2.1 grams, or from 2.21 grams of NO2? All right, so what we're saying is if we form 2.21 grams of this, we want to know how many grams of O2 are needed. That's what it's supposed to say. So 2.21 grams we have of this, and we want to know grams of O2. Before we begin, we have to balance the equation. I have 1 nitrogen on the left, 1 nitrogen on the right. I have 2 plus 1, 3 oxygens on the left, 2 on the right. If I put a 2 here, I now have 2 nitrogens, 2 nitrogens, 4 oxygens on the left, 4 oxygens on the right, and I am balanced. So my balancing numbers are 2, 1, 2. Okay, so step 1, balance the equation. Step 2, we have done as well. We've written down what we know, what we want to know. Step 3, let's start with what we have. 2.21 grams of NO2. In this problem, in the diagram, we are starting in the first box. We're starting at grams given. We're going to go the whole way over to grams wanted. So we're doing all the steps at one time. First thing we do to go from grams given to moles given is we multiply by 1 mole over the molecular mass of NO2. Nitrogen is 14, plus 32 for 2 oxygens gives me 46 as the molecular mass. 46 grams of NO2 for 1 mole of NO2. And it's important to keep those units in there and those labels in there so you can make sure things cancel out. So at that point, grams of NO2 cancel out. If I stop right now, my answer would be moles of NO2. That's not what I'm trying to find. So I do another step. My next step is to go from moles of NO2 to moles of O2, which is my wanted substance. My ratio of what I want of what I have is 1 over 2. I want the oxygen. There's a 1 in front of that, so 1 mole of O2 over 2 moles of NO2. So now moles of NO2 can cancel out. Again, if I stop right now and I solve, my answer would be in moles of O2, which again is not the units I'm looking for. I'm looking for grams of O2. So the last thing I need to do then is multiply by the molar mass of O2. O2 has a molar mass of 32 grams per 1 mole O2. So moles of O2 cancel out. Mathematically now, I take everything in the numerator, divide by what's in the denominator, and I get my answer. So I take my calculator, pull it up, and I put in 2.221 times 32 divided by 46. Now be careful when you do this next step, because I see a lot of people say 2.21 times 32 divided by 46 times 2. And when they do that, they put the numerator, and basically you're taking that 2 out of the denominator, putting it in the numerator. Every time you do that, make sure you hit divide again by that number. Divided by 2 equals. And my answer comes out to be 0.769 grams of O2. And again, I'm rounding to 3 sig figs. So my calculator says 0.7686. So that 6 rounds the 8 up to 0.769 grams of O2. All right, so stoichiometry again, to recap You start with it's when you're given a quantity of one substance in a chemical reaction, you're asked to find the quantity of another. When you do that, you balance the equation first. Then you write down what you know underneath the equation, what you want to know. From there, you figure out where in the diagram I'm starting, where am I going to. I can either start with grams given or moles given. I can either end with moles wanted or grams wanted. Remember, the moles wanted and grams wanted is of the new substance we're trying to find. You simply set up your problem and step your way through looking at the diagram. Eventually that will come to you and you won't need to look at the diagram. And then from there, you get your answer. Now you will be doing some practice problems of these types to get familiar with them. Again, this is a very essential part of this course.